Hey folks! Okay, well, now that we've talked about compilers and compiling, let's take a look at makefiles. So the idea here is that we can create a set of rules on when things should be recompiled, how to recompile them, and essentially just say make and whatever it is we want built, and let the makefile and the make program take care of figuring out what needs to be rebuilt and doing it. So there's the objective. Let's get into some of the gory details. I'm going to go through a bunch of the theory first, and then we'll back up and try an example, maybe the one from the lab on, or the section on separate compilation. So the idea is, again, we might have to deal with a project that's got a ton of header files and source code files. We might have a bunch of different executables that we need to build at different times. We might have these complex hierarchy of includes, and somehow we want to make sure that after we edit one of these files, we can recompile just exactly what needs to be recompiled. Nothing extra, but nothing missing either. So again, we need some way to define what needs to be rebuilt when, some way to describe the rules for recompilation, or for the initial compilation for that matter. So the idea is everything that can be rebuilt, so everything that can be compiled, is called a target. So every .o file is a target, every executable is a target, and when we want to rebuild something, we say make and then the thing we want rebuilt. So if there's a specific executable we want rebuilt, you know, my progx or something, we say make progx. And the make program will look in the current directory for a make file and look in that for the rules on how to rebuild that thing. And then for each of these targets, for each of the things that can be built, we'll have a list of dependencies that basically says if any of these things have changed or need to change, then the target needs to be rebuilt. And then also for each target, we'll have a rule specifying, okay, if you do need to rebuild it, here's how. So for instance, here's the g++ command to rebuild it. Again, all of this information is put in a file called a makefile. By default, you've got one makefile in each directory. You can actually tell make, okay, here's a different file I want to use as the makefile, but we'll skip over that for now. And again, we say make and whatever it is we want built, and the make program uses the makefile to figure out what to do about it. So the way a makefile actually looks, again, is this collection of targets, for each of them the dependencies, and then for each of them the rules on how to rebuild them. So just like in bash, you use the hash for comments, and it's, you know, for the rest of the line. And what we'll do here is assume that we've got four source code files, stack.h and then stack.cpp, so maybe that's got a stack data type defined in it. My prog.cpp and my prog.h, so maybe prog.h has got some, I don't know, constants and data types and stuff in it. And then my prog.cpp has got the main code for the program. So to do the separate compilation on them, you know, we do the g++-c on the two individual CPP files to turn them into .os, right, just like we looked at earlier. And then to link them together, we do the g++ on the two .os and a -o into the executable we wanted to create. So those three g++ commands are essentially the same ones we've been looking at before. We just need to figure out how to embed them into our makefile. So again, we have a target for each executable. So in this case, we've only got one executable, myprogx. So the way you show the targets is at the start of a line, myprogx, whatever the target name is, and then a colon. So we've got one for myprogx and one for each of the .os, myprog.o and stack.o. And then again, the rest of the information that's associated with that are the dependencies and the rebuild rule for that particular target. So the dependencies we just list on the same line. And essentially it's saying, if any of these are targets themselves, go off and see if they need to be rebuilt first. And if they're just plain old files, then see if they've been changed since the last time we rebuilt this particular target. So if I had a bunch of files in here and my myprog.o and my stack.o, it's going to say, okay, well, does myprog.o need to be rebuilt, and it's going to go check that. Does stack.o need to be rebuilt, and it's going to go check that. If there's some other file name here, then it's going to say, okay, has that file changed recently, more recently than my progx? And if it has, if any of those conditions are met, if any of these things have been updated or need to be updated, it's going to take care of that and then say, okay, now let's update my progx. So then it's going to do the g++ command below to rebuild my progx. Just one syntax note that is really annoying. That front character on the rebuild rule has got to be a tab. If you put spaces in there, the makefile will yell at you when you try and run it and say you've got bad characters or a bad command or something like that. So that's always a tab on that next line. So just as a heads up. So for my progx, we've got the rule that says if either of the .o's have changed or need to be rebuilt, go take care of that first and then rebuild my progx. And then again, we've got the rules for my prog.o. So up here, if it went through and checked and said, okay, well, we better check my prog.o, see if it needs to be updated. So it comes down here, finds the target, and says, okay, my prog.o or .o depends on these files. If my prog.cpp has changed, I've got to recompile. If my prog.h has changed, I've got to recompile. If stack.h has changed, I need to recompile. So if any of those things have changed, it'll go down and say, okay, well, here's my rule for recompiling. And again, there's a tab in the front, and then the g++ command. And then the same thing for stack.o. Right? This target for stack.o says, okay, well, if stack.cpp or stack.h have changed, recompile stack.o, and here's the command to do it. So that's essentially the way these makefiles are going to work and the way we lay them out in the file itself. And again, you can have multiple executables listed in a makefile. So if I had 5 different programs with code for them in this directory, I could have my foox down here or my whatever else it was. But when we say make my progx, it's just going to go through the dependencies for that particular executable, see if they need updating, take care of it if they do, and then finish rebuilding my progx. Okay, so again, this is just reiterating that tab syntax because it's going to bite everybody once in a while. That first character on the lines for your rebuild rules, it's got to be a tab. So there's got to be a tab in front of that g++. One thing to note, if you're using an editor that's automatically substituting 4 spaces for a tab or something like that, then you're going to have to turn that off before you edit your makefiles. Otherwise, it's going to stick spaces in there and things aren't going to work nicely. All right, so again, using the makefile, you can manually specify what you want to rebuild. So, you could say make stack.o and it'll actually go down to the target for stack.o and see if that needs to be rebuilt. But let's face it, most of the time, what we want to do is say, please rebuild this executable for me and let it go figure out which of the .o's and things need to be updated. Now, if all you type is make, then it just looks for the top target in the makefile and assumes that's the one that you want to use. So it defaults to whatever's first in the makefile. So in the example we had here, if this was our makefile, it's going to go through and say, if they just type make, the first thing in there is my progx, so it's going to try and rebuild my progx. All right, and again, this is essentially what I described in the example there. The way the makefile works is it goes through the list of dependencies for your target. So it looks through for the target, for instance, my progx. If any of the things on its dependency line, so for instance the .o files, if any of those have their own rules in the makefile, then it treats them as intermediate targets, goes off, sees if they need to be rebuilt, takes care of that if they do, and eventually comes back and continues on with our list of dependencies. After it goes through all of the dependencies, if any of them have changed, and again, this is if any of them have changed more recently than the last time we actually rebuilt the target, then we run the rule to rebuild the target. And all it really does in terms of figuring out what's most recent is it looks at the last date that the file was modified for the executable, the target, and the last date the other files have been modified, last date and time. So that'll be accurate down to a second or so, I believe. Now, if the target doesn't exist yet, so that'll typically happen if this is your first time compiling the program, then it automatically builds it. All right, so again, if we typed something like, with that particular example, make prog_x, it's going to go through the dependencies for the 2.0 files, sees they both have rules, goes off and checks them, so it'll go off and check, whichever one's first in the dependency list, and go off and process it if necessary, and then come back and check the other one, and go off and check its rule and its dependencies, rebuild those if it needs to, and then come back, and then go through and take care of your rule for myprog_x, or your rebuild instruction for myprog_x. So again, it's just this series of dependencies. Do I need to rebuild that? Oh, I better go off and take care of it. Do I need to rebuild that? Oh, I better go off and take care of it. And eventually it finishes those off and comes back to wherever we left off. One thing I did want to mention was we can have multiple commands in a row with one of our rules. And you can use things like the echo to print out statements as your makefile runs. So for instance, if I say, before I run the compilation command, if you've got 50 or 60 different compilation commands, sometimes it's handy to have a little bit of output appearing that shows you what's actually what it is you're trying to rebuild at the moment. So you might throw in an echo statement that says something like, myprog or myprog.o needs updating or some such thing. So you can throw in these echo statements. The way the makefile works is that every time it sees a command to carry out during the rebuild process, it prints out the command first and then it runs the command. Which most of the time is fine. It'll show you that I'm doing g++-c myprog.cpp-o myprog.o, and then it runs the compilation command and you see any errors or warnings that pop up. But with things like the echo command, that doesn't make a lot of sense. What it'll do is print out echo myprog.o needs updating, and then the echo will run and print out myprog.o needs updating. It's a little on the redundant side. So you can silence those commands if you want by throwing an @ sign in front of them. So if you throw the @ sign in front, then in front of one of these commands, then in front of one of these commands rather, then it doesn't actually print the command before it runs it, which is typically the place you'll see that most often is with the echo. But if you've got something else that you don't want displayed before it runs, then just throw the @ sign in front. All right, this might be a good point for us to actually play with an example here. So actually, what we'll do is let's use the example from that separate compilation session that we did, where we had 4 files. We had some kind of basic data type or data files. We had a linked list, we had a tree, and we had a program that made use of both of them. So each of the .cpp files include their own .h file. Prog.h includes the list and the tree, and both the tree and the list include that data file. So this is the example that we're going to use. We'll create a makefile for this, and I'm going to create just some sort of goofy files for the actual content of these .h's and .cpps. So this is the example that we're going to play with, and we'll just experiment with it for a little bit here. So let's see if I can get this up and running. Alrighty, so what I've got here, let me just remove the prog_x for a moment. So what we've got here are the 4 .h files that we mentioned, and the 4 .cpp files, right? One for prog_h, tree_h, list_h, data_h, and then the same thing for the .cpps. And again, if we want to take a look in them, let's start with the data. So again, I've just put together some kind of Mickey Mouse content for these things, but so for the data file, I'm just going to have a simple check-in function. So nothing exciting, just so I've got some content in it. And again, if you remember, we talked about this idea of having guards so that things couldn't be included multiple times. So the if not def data h, define it and include the content for this header file. And then in the data.cpp, what did I do there? So this is basically just a quick counter that prints out how many times you've called check-in. So again, nothing very fancy, just so we've got some content here. So every time you call check-in, it updates the count of how often check-in's been called and prints it out. And then for the list.h, we're going to fake a linked list. We're just actually going to use an array for this. So I've got a list data type that can hold up to 10 elements, and again, it's really just an array. We've got an insert function and a print function. So we can insert an integer into the so-called linked list, and we can print the so-called linked list. And the insert and print routines, again, they're basically just adding one element to the array or printing the contents of the array. We've just got a couple of global variables. Again, this is real dirty code for keeping track of the list content. So we can only actually have one linked list at a time, and we can only have, you're going to see the same thing with our tree. I'm going to use the exact same idea with the tree. Our so-called tree is actually just going to be an array with an insert and a print routine. And I believe I used pretty much the exact same code for the inserts and prints. So we've got a t insert and a t print for the trees, and an l insert and an l print for the lists. And then our prog.h is just going to figure out how many elements we're actually going to use. And our prog.cpp, I think, is just going to call that check-in, and an L insert and a tree insert for, up to 5 elements. And then print out the list at the end and print out the tree at the end. And again, the idea is just to make sure that we've got, different functions in each of our .cpp files. Prog's using all of them. We've got this kind of hierarchy of includes, and we want to make sure that we can compile all this and get it all to work together. So again, if we were doing it manually, we would do the g++-c for each of the 4 .cpp files, and then we would do a g++ on all of the .o files to create our executable. So our makefile does pretty much exactly that. So for our makefile, we've got a target for progx, which is going to be our executable, and it says, okay, well, I'm going to compile those 4 .o files together. So if any of those .o files don't exist yet, or need to be updated, or have changed since I last built progx, then print out a message saying, okay, I'm rebuilding progx, and run the compilation command to do that. And then for each of the .o files, we'll have the same sort of idea. For prog.o, we'll say, okay, if prog.cpp has changed, or prog.h has changed, or any of the other .h's have changed, rebuild prog.o. Or for that matter, if prog.o doesn't exist yet, rebuild it. And again, it's just the g++-c command to rebuild it. Same for each of them. It lists the .cpp file it depends on, and each of the .h files it depends on. Right? So we've got our collection of targets, the dependencies for each of them, and then the rebuild rule for each of them. And again, you notice in the front, we've got a tab as the first character for each of those instructions underneath the target, each of the rebuild, or each of the pieces of rebuild information. So, in theory, if I go through and use one of them in particular as a target, so if I say something like, let's make prog.o, then it's going to go off and find that target and tell me, okay, that thing needs to be rebuilt, and it'll rebuild it. If I try it again, prog.o hasn't changed, or none of the dependent files have changed, right? I just ran this, so it tells me it's up to date. So we can do that if we want to make a specific one. Again, usually I'm just going to type make progx because that's the executable I want to rebuild. And this should go through and figure out that, well, prog.o is okay, but it should figure out that the other .o files all need to be built because they don't exist yet. And it goes through and it rebuilds the list, it rebuilds the tree, it rebuilds the data, and then it builds my executable. And so now hopefully I've got all of those handy. Right, so I've got all my .os and I've got my executable, and maybe it even works. Yeah, so it goes off, calls check-in on each of the 4 passes through its main loop there, and then prints out the list and prints out the tree at the end. So it did actually work. Yay! All right, so that's the basic idea. Let's go back and look at some bells and whistles here. Now, we can add what they call phony targets, targets that don't have a dependency but can do something for us. So if I've got actions that I want to be able to carry out as part of the makefile, so if I want to be able to type in something like make clean and have it remove all my .o files, I can do that as well. So in our makefile, we stick something that says clean is going to be a phony target. We put it in as a target. Oh, that should actually be a lowercase c if I'm going to be consistent here. So we put it in as a target, no dependencies, and then on the next line, we have the kind of bash instruction that we want to run when somebody types make clean. So again, in this case, we're going to do a remove on the 2.o files and the progx. So let's give that a try in the makefile we just created there. So let's go through, and I'm going to stick this at the bottom. So I'm going to add a target. Oops, I should specify that this is a phony target. I'll add clean as a target with no dependencies, throw in my tab there, and then say, okay, I want to remove, and -f is just saying force, don't ask me if I want to remove each of them. My list.o, oops, it's list, isn't it? List.o, data.o, tree.o, and prog.o. Maybe if I clean it up, I want to remove the executable too. So this is basically just to make sure that all of the rebuildable targets are removed so I can get a clean, fresh build from scratch, if you like. So now if I type make clean, it should go through and remove all those. And yes, they're all gone. So now if I type in, oh, actually this is a good chance to try out just make by itself too. Remember, make by itself just grabs the top target in the list, which in this case was progx. So it should go through and rebuild everything. Yeah, and we've got it rebuilt. All right. Let's see, so we've got phony targets. Sometimes if you've got multiple executables in a directory and you want to be able to rebuild all of them, what we can do is use all as a target right at the top, and then as its dependency, just stick in each of the executable names. Then if we just type in make, it goes through, sees that all target is the first thing, and then goes through the names of the executables and checks to see if each one of those needs to be rebuilt. So let's throw that in here. Oops, should show you what I'm doing. So I'm just going to add a target named all. And I guess in this case we only have one executable, but you can go through and create a list here that's got all of the executables in the list. And if I just type in make, it'll go through, grab the all, and check each executable in that list. So in this case there's nothing to be done because I just modified or just built my progx. So let's do a make clean and a make all. And again, this should go through the list for all and rebuild them, which in this case is the progx. All right. Let's see, what are some of the other bits and pieces that I wanted to mention? Touch is a useful command for testing your makefiles. So if you type in touch and a file name, it changes the modification date of that file. It doesn't change the file content, but it changes the modification date, so it looks like it just got altered. So as far as make is concerned, it thinks, oh, I need to rebuild whatever the items are because this other file just got rebuilt. So it's a little safer than, if you want to test your make files, one way you could do it is by actually editing each file, inserting a space or removing a space or something like that. But anytime you edit a file, there's a chance you're going to goof and do something you didn't want to do. So this is just a safer way of making make think that something has altered, has changed. So again, if we wanted to see that in action, right, if I type make prog_x, it tells me, oh, nothing needs to be done, everything's up to date. But if I type in touch, I don't know, prog.h, then it thinks prog.h has now been changed, right? If we do an ls-l, we see the modification dates of all these things. Where's our prog_h here? Right, so prog_h just got altered. So now if we do a make, it realizes that, prog.h has been changed, so-called, so it needs to rebuild prog.cpp, or prog.o rather, and therefore it needs to rebuild prog_x as well. So you can play with that as a sort of testing technique for your make files to make sure that they're actually rebuilding the right things when something gets updated. All right, I also wanted to mention the use of variables in make files. So the idea is, we've, again, quite often got long collections of things that we want to use over and over and again in a program. Usual problem, if you want to change that, you have to go through and change it every place that it's used. So for instance, maybe I want to throw in -wall and -wextra for all of my G++ commands. So I can go through and manually stick -wall, -wextra in every single one of them. But if I try to change that later on, it means I've got to go through and edit every single one of them. So what I'm going to do is stick these in a variable and just use the variable in each of the compilation commands. So the way you do it is by picking a variable name, just whatever you like, equals and whatever value you want, whatever text you want associated with it, and then use the dollar and curly brackets around the name of it to actually use the variable later on. So let's try exactly that in our makefile. Right, so I say something like, okay, well, I want my list of, let's call it flags this time. I always use flags. So flags are -wall, -wextra. So these are going to be the compilation flags I want to use all throughout this. So for each of my G++ commands, I say, okay, well, I want to use my flags here. And we'll just do the same thing for each of those. I'll do a make clean so we can see all this in action. And we'll do a make, and it rebuilds all of them, and you can see that it's embedded the -wall, -wextra in each of those. So we can use variables. Actually, another place that we might want to use variables in this particular make file is the, let me see here. I might want a variable for the list of .o files that I want to be able to remove. So up here I can stick the list.o, data.o, tree.o, etc. in a variable, and then down here just say, okay, remove, stick in the variable name, and it'll remove all those. Let's see. You can override that from the command line. So from the command line, if I want to use something different than what the variable says, I can use the variable name equals and then whatever I want to use instead, and it will use that instead. Right? So if in that example I just did, I wanted to do make flags equal, and we'll use the -g option, then it'll use that instead of the wall extra, I hope. Oops. Of course, there's nothing that needs to be updated. And there we are. We see it's using the -g instead of the wall extra. Alrighty. There are a handful of special variables in make. So if in the command, so your rebuild command, if you use the $@, it just refers to whatever the target name is. And if you use the $, it refers to whatever the first dependency is in that list. So if I was to go through and let's say for my prog.o, right, the target is progx and the first dependency is prog.o. So in here, if I say $less than, again, it just uses that prog.o, and if I use the $at, it uses the progx. It can be handy in terms of making sure that you don't have typos in your command, and make sure that it automatically uses the right name for that particular file. So if we do a make clean again, and hopefully I haven't messed anything up, yeah, everything works out okay. All right. Now, there is a ton more to Makefiles. There are a huge number of other options. There's a lot more that you can do with this. But again, this gets us started. It gives us a kind of a working base. I guess the only other thing that I should mention here is the use of paths in our file names. So let's say that we actually had, I don't know, I'm gonna make a prog directory, and I'm going to move prog.h, for instance. Or no, let's move oh yeah, let's move prog.h in there. So if the file that we're interested in is in a subdirectory someplace, then you just have to make sure that in your makefile, any place where you refer to it, you include the path. So where have we got a prog.h? Right here. Right, so you have to make sure that you include the path to it. And that includes the target names. If you want your executable, or if you want your .o files to go into a directory someplace, then you have to make sure that you use the directory name, or the path, as part of the target, and as part of wherever it appears in a dependency list, and as part of wherever it appears in a command. Right, so if you have things tucked away in directories, make sure that every place in your makefile refers to it by the path and the directory, or the path and the file name. All right. Okay, well, that was a bit of a longer session for us, but again, this is the fundamentals of makefiles. If you are doing compilation using an IDE that's taking care of this stuff for you, this is essentially the kind of thing that it's doing behind the scenes. So you should understand this, even if you're in the fortunate situation of not needing to create your own makefiles. All right, we'll leave it there and tackle more things next time.